Okay, so this video is for the DoNow for the second lab that we're going to do. And that second lab revolves around vectors. So these questions, all these questions here, basically get at the core of what you're going to be doing for the lab. The lab is online. And this is classwork. At least I'm making this video in 2023. I'm not sure if I'll use it in subsequent years. I might, but for now it's classwork 7. Maybe later it might be a different number, but I'm sure it'll be similar questions. See, even the day I made this particular this file was last year. You can see 2022. So who cares? That doesn't really matter. All right, so let's begin at the beginning. So first we have add these three vectors: 5 meters east, 10 meters east, and 15 meters west. Now, you could draw this with a ruler and protractor, but you can kind of also think of these things logically, because east is to the right when you think about it. And then, so here we are again, east 0 degrees, or right. And then west is 180 degrees, or left. So we have, and again, you could do this to scale if you wanted to, but we have 5 meters to the east. So it's kind of like 5 meters, right? 5 meters to the east. Then double tap is supposed to erase. Why is that not working? Here we go. I got my double tap to work. This pen maybe is getting old. But anyway, so I have 5 meters to the east and then another 10 meters to the east. And so all together, that gets me 15 meters to the east. But then we have a third vector, and it says 15 meters to the west. So if I start from there, from the end of that vector, and I go 15 meters to the west, right there, where do I wind up with but nothing? I'd start right back where I started. And so I have a resultant of 0 meters. Okay, number 2. So it says I have 2 components, x component and y component. It says find the magnitude and direction of the resultant they make. So I have a positive x component and I have a positive y component. That's going to put me in the first quadrant. I could draw this with a ruler and protractor, and I could figure it out that way. I'm going to sketch it on my tablet, but then I'm going to show you how to figure that out with right triangle trigonometry. So I took those 2 components and I treated them like vectors and I made a chain. And so my resultant, what I'm actually the magnitude and direction that I'm going to find, there it is right there, start to finish. But I want to know what is the magnitude of that vector and what is the angle of that vector. So if I have the 2 sides, this is a right triangle, of course. So I have the 2 sides of a right triangle, I can find the hypotenuse with Pythagorean theorem. So I square the 2 numbers, and then I add them up, and I take the square root, and I get 100. And that would be 100 meters per second. So that's the magnitude of the vector. Now I need to find out what the angle is. Well, now that I know the hypotenuse of the triangle, I could really use sine, cosine, or tangent to solve for theta. But I'm starting off with the 2 sides of the triangle, so why not use tangent? So there's the work. Tangent of theta is opposite over adjacent, and if we're measuring theta from the x-axis, the opposite will always be the y component. So that would be y over x. And so y is 80 and x is 60, both meters per second. Notice that I wrote the equation and I put the numbers in with their units. Then I do 80 over 60, that I get 1.33 for that. And so then I go to solve for theta. I need to get theta. So tangent of theta is 1.33. So I take the inverse tangent of that on the calculator, calc. That would be second tangent. And so I'm going to do second tan of that, second tangent of that number, the 1.33, and I wind up with 53 degrees. And so this particular, the magnitude is 100 meters per second, and then my angle is going to be 53 degrees. Let me pick the right eraser. There we go. And so 53 degrees. And whenever you have two components like that, and you have an x component and a y component, and you need to find the magnitude and direction of the vector they make, you have to do Pythagorean theorem to get the magnitude, kind of like the hypotenuse of the right triangle they make. And sine, cosine, or tangent to get theta, I would use tangent, but that's just my personal preference. That's going to get you the reference angle, by the way, which we don't need to do anything with the reference angle here because we're in the first quadrant. So that would be 100 meters per second at 53 degrees. I can even kind of write that. A equals 100 meters per second at 53 degrees. Okay, great. Next question. Okay, so number 3, I have two vectors a and b and their resultant, and it says use ax equals a cos theta and ay equals a sine theta to find the x and y components of each vector, then compare. So I'll write out the work for the first, for a, and then I'll just kind of like write the answers for b and for r. So for a, all right, so there's the work for the two components for a. I get 3.46 and 2 for x and y respectively. Of course, the components have the same units as the vector they started from, so they would both be newtons. I'm going to do the same thing for b and for r. So b at 5 newtons at 60 degrees, you wind up with 2.5 newtons and 4.33 newtons for x and y respectively. And then the resultant r, and right, so then I add up the x components. I'm sorry, I found the components for the resultant. 5.96 newtons for x, 6.33 newtons for y. And then it says compare the components once you've found them. So if you take a close look at the a and the b and the r, you might see the relationship that the x components add up to the x components of the resultant, and the y components add up, add up to the y components of the resultant. How you like them apples, right? All right, anyway, next. Number 4, use delta tip to add these vectors and determine their resultant. And you could do this graphically, but we also can kind of do it logically. Let's sketch it out. They're all 6 meters, and we have 0, 90, 180, and 270, kind of going around in a circle. So 6 meters at 0 degrees, that would be to the right, that way. And then we have, call that A. Then you have 6 meters at 90 degrees, so same length but straight up, we're going to call that B. Then we have 6 meters at 180 degrees, that would be to the left, that would be C. And then we have 6 meters at 270 degrees, and what the what? We wound up back where we started. And so we know that when we wind up back where we started, if you start and stop in the same place, your resultant actually winds up being 0. So no resultant for number 4. And number 5 is pretty quick. It says velocity vector v of 44 meters per second east. So v is 44 meters per second east. And I was like, what would negative v be? So if you remember from the notes, negative means to turn around. Reverse it. So negative east, negative east is the other way, west. So negative v would be 44 meters per second west. Now be careful. Don't say negative 44 meters per second west, because then you're saying negative west, which is east again, right? So that's like saying, like, it's like kind of like taking care of the directions twice. So just be aware of that. If v is 44 meters per second east, negative v would be 44 meters per second west. And here is the last question in the set. Given these vectors, find the resultant. I have 50 newtons at 0 and 50 newtons at 90. And then we have to find what's called the equilibrant. So let's find the resultant first. Got two vectors, they're at right angles, and so of course my resultant is start to finish, and I can treat those two guys like a right triangle. So when you work the math, you get that the resultant is 71 newtons. I could also use the angle. And actually, I'm kind of writing this out quickly, but then I realized that the two sides are 50 and 50. It's a 45-degree right triangle. And if you take the inverse tangent of 1, that is exactly what you get, 45 degrees. So the resultant would be would be northeast, really, 71 newtons at 45 degrees. Now the equilibrant, the heck is the equilibrant? This is the vector that'll cancel all other vectors. The equilibrant is the same magnitude, but the opposite direction of the resultant. So if that resultant is in the first quadrant, then the equilibrant going the other way is in the third quadrant. Call that E for equilibrant. And so that E, the equilibrant, would be the same amount, 71 newtons, but the angle, so this would be 45 as a reference angle, but then we would add 180 to that, so the equilibrant would be 71 newtons at 225 degrees. So there you go. And that was the last question. That's kind of a long DoNow. Usually the DoNows are not that long. But if you have that, that kind of helps you walk through what you need to do for the lab. So the lab's all online using the PhET app, and so just follow the questions and you should be good to go. All right, thank you.